Good morning, everyone. Let us start this session. So, in this session, we will solve the problem on the equilibrium of connected spheres. So, in the last lecture, we have solved one problem on the connected pipes. So, now down the next problem. So, in this problem, two spheres, one having the weight 20 kilonewton, that is a sphere A, and the second sphere, it is having the weight 40 kilonewton. Okay. So they are supported by this inclined wall having the inclination 60 degree and this vertical one. Okay. And the question is we have to find out. So determine the support reactions at the contact points. Okay, so in the given system, total we have, this is first contact point, this is second, and this is third contact point. Okay, so these contact points, they are nothing but the supports given by this wall to the sphere, and there is one contact between the sphere A and the sphere B. So this is the common point for both the spheres. So here we have to find out the reaction R1, reaction R2, reaction R3. Okay, so for this, we will draw the free body diagram. So that is your first step. So in the free body diagram, you need to isolate this system from its surrounding. Okay. So this is the first sphere. So you can draw two separate free body diagram, one for sphere B and second for the sphere A. Okay, so here we have isolated both the spheres simultaneously, A and B. Okay, and here next step is we have to show the support reactions and the weight force. So the weight force, it will act from the center point of each sphere in the vertically downward direction. So this is the 40 kilonewton. And for the sphere A, we have the weight, which is 20 kilonewton. Okay. Now at this point 1, there is one support reaction when we isolate this sphere. Okay. So this support reaction will be like this. Okay. So it will be exactly perpendicular to this inclined surface. So this angle, this is 90 degree. Okay. So as this is 90 degree, this total angle is 60 degree. That means this angle is 60 degree. So this angle, that is angle of this reaction R1 with respect to horizontal, it will be 90 minus 60, that is a 30 degree. Okay. So whenever we show the reaction in this free body diagram, so this is your sphere B and this is sphere A. So we will show the reaction like this. And this reaction, that is this line of action, it will pass through the center point. Okay. And if you draw one horizontal line, then this angle, it will be 30 degree. Next, we have the contact at this point, which is a point 2. Okay. And here, the surface is exactly horizontal. So the reaction will be exactly vertical, or it is perpendicular to the horizontal surface. So this is your reaction R2. So this is the reaction R2, exactly vertical. And it will pass through the center point. So 40 kilonewton and R2, both are collinear vectors. After that, there is one reaction R3 at this point. So here reaction R3 will be like this. Okay. As this surface, that is this wall, is exactly vertical. So this reaction R3 will be exactly horizontal, or it is perpendicular to the vertical surface. So here you can show the vector for reaction R3 like this. Okay. The line of action of R3, it will pass through the center point. Okay, so here we have shown all the reactions R1, R2 and R3, and two weight forces 40 kilonewton and 20 kilonewton. Okay. Next step is we have to use the conditions of equilibrium. Okay. So we have three conditions: summation fx0, summation fy0, and summation of moment 0. Okay. So if you observe, then the reaction R1 and reaction R2, they are passing through the point B. Okay. So if you take this moment about the point B, so if I write the equation like this, summation of moment by all the forces about the point B, this is equal to 0, then we can cancel out the moment by reaction R2, reaction R1. Okay. So there is only one reaction, which is the R3. So this single equation, that is summation of moment, it will directly give the value of the reaction R3. Okay. And after that, to find out the reaction R1 and R2, you can use summation fx and summation f1. Okay. So to use this equation, we must have the perpendicular distance of reaction R3 from the point B, and it is not given in the problem. Okay. So we need to find out this from the given diameter. So here phi means diameter. Okay. So for this sphere or for this circle, its diameter is given as a 1.5 meter, and for this sphere diameter is, this is 1 meter. From this given diameter and the given angles, we need to find out the perpendicular distance of reaction R3 from the point B. So we can make one construction. So connect this center point of sphere A and B. Okay, and from this point, just draw one perpendicular or draw one vertical line, and from the point B, draw one horizontal line. Okay, so just assume this point as a M. This is point A, this is point B. Okay, so actually your force, which is a reaction R3, it is acting at this point, which is reaction R3. Okay, so for the reaction R3, from the point B, what is the perpendicular distance? So distance AM is the perpendicular distance for the reaction R3. Okay, but how to find out this distance? So distance AB is known. Okay, so we need to add the radius for cylinder sphere A plus sphere B. So that radius will be, so distance AB we can write. So radius of A plus radius of circle B. So this is equal to, for A it is 0.5 and for B it is 1.5, that is 0.75. Okay, so this will be 1.25 meter. Okay, so now we have got the distance AB. Now we need this angle. Okay, so angle of the line AB with respect to horizontal or with respect to BM, but it is not given in the problem. Okay, so how to find out this angle? Or we can find out the distance BM. Okay, so for that, just observe the sphere B. Okay, so for the sphere B, this is contact point 1, this is contact point 2. So we can draw this vertical line, and here we can draw the line. Okay, so two lines, they are exactly perpendicular. So from this common point, actually we have drawn two tangent line to the same circle. Okay, so if you connect this point with the center of the circle, then it will bisect this angle. Okay, so this angle, this is 60 degree. This total angle is 120 degree. So this is 60 and this angle will be 60. Okay, so actually so here we have the common point, and this is the tangent surface. This is second tangent surface. Okay, and this is the center of that circle. So we can draw, so we can connect this tangent point with this center point. Okay, so this is 90 degree. This is 90 degree. And if you connect this point directly with the center, then it will bisect this angle. Okay. So in the problem, this angle is given, which is 60 degree. This total angle is 120. So this is 60 and this is 60. Okay. So this is 90 degree. Now here we can find out this distance. So this distance, let us assume this as a x. This is the radius for the sphere B. This is 60 degree. This is 30 degree. Okay. So we can get the value of x by using tan 30, which is equal to opposite side is x upon adjacent is radius RB. Okay. So x is equal to RB, this value is 0.75 into tan 30. So x distance, this is equal to this is 0.43. Okay, so actually this distance is required in order to find out distance BM. Okay, so here you can observe from this point up to this vertical wall, total distance is 1.5. Okay, so if you want to find out the BM, then we will subtract this distance, which is a x now, from 1.5, and again we have to subtract this distance. Okay, that is from this center up to the vertical wall, and this distance is nothing but the radius of the sphere A. So required distance BM, this is equal to total 1.5, this distance, minus distance x minus radius of sphere A. So this is equal to 1.5 minus 0.43 minus 0.5. So it is 0.57. Okay, so distance BM we have got as a 0.57. Okay, this distance is 1.25. So observe the triangle. This is the point M. This is A point and this is a B point. Distance AB, this is equal to 1.25. Distance BM, this is equal to 0.57. So by using Pythagoras, you can find out the perpendicular distance BM. So this perpendicular distance, AM for the reaction R3. Okay. So use the Pythagoras. So you will get the distance AM, this is equal to in the square root 1.25 square minus 0.57 square. Okay, so this is equal to it is 1.11 meter. Okay, and then you can use this equation, summation of moment about point B is equal to 0. Okay, so use summation of moment by all the forces about the point B is equal to 0. So we will start from reaction R3. Okay, so reaction R3 into, so what is the perpendicular distance for reaction R3? This distance AM, it is the perpendicular distance. So AM is 1.1, and this moment about the point B, this is anti-clockwise. Okay, so this is positive. Next we have this weight force, which is a 20 kilonewton, into perpendicular distance for 20 kilonewton. So if you extend this line, then this distance BM is the perpendicular distance for 20 kilonewton. Okay, so 20 into 0.57, and this moment will be clockwise about the point B, so it is negative. So we have only two forces, other two forces reaction R1 and R2, and this weight 40. All these forces, they are passing through point B, so their moment is 0. So this is minus, and this is equal to 0. Okay, so directly you will get the reaction R3 from this equation. So this is equal to, so reaction R3, this is equal to 10.27 kilonewton. Okay, so this is your first unknown out of the given three unknowns, R1, R2, and R3. And then you can use summation Fx and summation Fy. Okay. So now use summation Fx0. So for the summation Fx0, consider all x component. So we need to resolve the forces. Okay, so R1, it is actually inclined by 30 degree. So you can resolve the force like this. So this is R1 cos 30, and this is R1 sin 30. Okay, and all other forces, they are exactly horizontal or exactly vertical. So summation Fx will be R1 cos 30 positive, then minus R3, this force. Okay, only two forces in the x direction, and this is equal to 0. So you will get the reaction R1, this is equal to R3 upon cos 30, and R3 just we have calculated, it is 10.27 upon cos 30. So this is 11.25, sorry, 11.85. Okay, and then use summation Fy, this is equal to 0. So for the summation Fy, this is the y component, which is the R1 sine 30, then plus reaction R2. So this is the reaction R2, and then this 40 and this 20. So minus 40 minus 20. We don't have any component of reaction R3 in the y direction. So this is equal to 0. So from this, calculate the reaction R2. Put the value of R1, which is 11.85 kilonewton. So your reaction R2 will be this minus 20, minus 40, minus 20, minus 60. On the right hand side, it is plus 60. And this is minus R1 is 11.85 and sine 30. Okay. So calculate this value. This is 60 minus 11.85 sine 30. So this is 54.1 kilonewton. Okay, so this is the reaction R2, and its direction is positive y direction. Okay, so in this way you can find out the support reactions for the connected spheres. So here important is you should draw the proper periodic diagram, and you have to find out some unknown distance and unknown angles. And if in the question, if you want to find out the reaction at this common contact, then you need to isolate both the spheres. You should draw a free body diagram for the sphere A and sphere B. So let us see how to draw that. So if you want to find out the reaction at this contact point contact point between A and B, then you can draw two separate free body diagram like this. Okay. So in this free body diagram, at this point, you will have the weight force in the downward direction. Then this is the reaction R3, which is exactly horizontal. So this line of action, it will pass through the center point E. Then at the common contact, we have the reaction. So when you draw the reaction for sphere A, show the reaction directed towards the point A, like this. And it will pass through the center point. And for the second sphere, this reaction, it will be exactly opposite, like this. Okay. And this will pass through the center point of the second sphere. Then here you will have the weight force in the downward direction. This is the W. Then at this point, there is one reaction, which is a R1. Okay, so this will pass through the center point, and its angle, this is equal to 60 degree. Sorry, this is 30 degree. Then at this point, we have vertical reaction, which is the R2. Okay. So this reaction, it is the common reaction. So we can take this reaction as a R4. This is the point B. So this is the free body diagram when we separate out sphere A from the sphere B. So even you can solve the complete problem by considering two separate free body diagram, one for sphere A and second for the sphere B. So whenever you consider sphere A, just observe the unknowns. You have R3 unknown, R4 unknown. Okay. So actually this system for this sphere A, it is the concurrent force system. So you can use summation Fx0, summation Fy0, and by using this, you can find out R3 and R4. Okay. Or you can use the Lamest theorem. Okay. So for the Lamest theorem, you can draw this free body diagram like this. So weight force, it will act in the downward direction. So this is the W. Reaction R4, you can just show from this point directly to the point A along its line of action. Okay. So we can show the reaction, which is the R4 in this way. So actually, this is the line of action, and this reaction R3 we can show along this line of action. So this is the reaction R3. Just we have to shift the force from the periphery of the circle directly to the center point. Okay. And now here you can see there are three forces at the single point, which is the point A. So we can use the Lamest theorem. Just we have to find out the angle. Okay. So how we can find out this angle? So for the reaction R4, we need to find out this angle, because R4 it will act along this line. Okay, for the R4 angle is not 30 degree. 30 degree it is the angle only for reaction R1. So line of action of R1 and line of action or line AB, okay, they are not collinear. So in this free body diagram, it looks like as both are collinear, but actually angle is different. Okay. So this angle, let us assume this angle to be alpha. So this is alpha. So alpha you can find out. This is equal to tan inverse this opposite side, or you can use not tan inverse. Just use cos. Okay. So you will get cos alpha. This is equal to adjacent is 0.57 and the hypotenuse is 1.25. So by using cos inverse, you will get the angle alpha. Put the value of alpha. This is 90 degree. So this total angle, this is 90 plus alpha. Now this total angle directly it is 90 degree because R3 is horizontal, W is vertical, so angle is 90. And this remaining angle will be, this is 360 minus 90 minus 90 plus alpha. Okay. And then use Lamest theorem. So this is second method when you separate out sphere A from the sphere B. Or you can draw a single free body diagram and you can use three conditions: moment, summation of x, summation Fy. So when you isolate the sphere A from the sphere B, you cannot use summation of moment 0. Okay, because both the systems they will be concurrent force system. Okay,